Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Friends, we have already completed the first part of the dielectric materials. That is, we have discussed about what is the various mechanism of polarization in dielectric materials, and we have discussed about some introductory concepts like parameters of dielectrics and what is the difference between dielectric and insulators. So everybody who is joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Yes, everybody. Till then, you are going to report me this. Let me just brief you that this session belongs to the non-tech express. What is the aim of this series? The aim of this series is Engineering Services 2023 Prelims Examination. This series is going to provide you a comprehensive coverage of all the General Studies Paper 1 10 topics. Already a lot of subjects have been started. I have also started engineering ethics. Some lectures I have taken for engineering ethics also. This session, I will be talking about material science. So yesterday, last class, we discussed about the mechanism of polarization, and today we'll be talking about the types of dielectric materials. Is it clear? So everybody who is joining me live, just quickly like, share and subscribe the session. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from ITBHU in 2010, written a couple of books, and these are my areas of expertise. Before we start the session, there are some important information I want to share with all of you so that you get the best guidance for your preparation. Right now, we are having the GATE Aimer series, which is a free crash course for electrical, electronics, instrumentation, computer science. Already, it has started from 14th of November on YouTube, so you can join these sessions. Also, you can attend the scholarship test to get the 90% up to 90% discount, and the new series which are running on the BYJU'S Exam Prep app, that is GATE 2024 and GATE 2023. The GATE 2024 series is focusing upon the fundamental concepts because you have enough time to build your concepts, whereas for GATE 2023 we are having the rank booster series. I am also going to take some important sessions in this particular series for power systems, so all electrical candidates be ready for that. All these sessions you can take in the live sessions on BYJU'S Exam Prep app. So everybody who is joining me live, just quickly confirm your presence so that we can start. So let us understand what is the classification of dielectrics on the basis of their behavior in the presence of external electric field. So we have piezoelectric materials, pyroelectric materials, ferroelectric materials and antiferroelectric materials. Let us start with the piezoelectric material. If you talk about the piezoelectric materials, these are the materials when you apply some mechanical force, then these material gets polarized. On the contrary, if you apply some electric field, there is some strain produced in these materials. So it has basically two effects. Materials which get polarized because of the application of the mechanical stress are called as piezoelectric material. The reverse is also true. With the application of electric field, these materials get strained. Strain means there is some change in their mechanical dimension. So these two effects we are defining as the direct effect. What is direct effect? Polarization because of the mechanical stress. The application for this effect is microphones. The inverse effect is the mechanical strain produced due to the application of electric field. The best example of the application is quartz watches. The examples of piezoelectric materials you can take is quartz, barium titanate, lead titanate, lead zirconate and Rochley salt. Rochley salt is one of the first piezoelectric material which was discovered. Okay. Let us talk about the application of piezoelectric materials. Piezoelectric materials are used as resonators, flow detectors, filters and accelerometer. And I will give you a fine understanding that anywhere if you want to transform the electric field to mechanical effect means force or some strain, stress or strain. On the contrary, if you want to transform the mechanical effect, that is force or pressure, into the electric field, then you can use the piezoelectric materials. Maniket is saying PDF nahi mil raha hai. You can join the BYJU'S Exam Prep Telegram channel. The link is given in the description of this video. Otherwise, you can join my personal Telegram channel, that is Electrical by Ashutosh Saxena. That is my name. So just after the session, I will be uploading the PDF. Is it okay, Mr. Maniket? Okay. Before we go to the next part, a very important information for all those candidates who are seriously preparing for GATE and engineering services examination. We have free workshops, and these workshops you can attend by getting yourself registered for these workshops on the BYJU'S Exam Prep app. There is one more phenomena that is called as electrodestriction. The difference between electrodestriction and piezoelectric effect is very fine, so you have to understand it and you have to remember it. Materials which develop strain when an external electric field is applied, but the reverse is not true. It means if you apply the mechanical force, if you apply the pressure, then these materials are not going to give you the reverse phenomena. It means when you apply the electric field, there will be mechanical effect. But the reverse is not true. Whereas in case of piezoelectric material, both direct and inverse effect was present. Now, for electrodestriction phenomena, the strain, that is the mechanical strain produced in the material, is directly proportional to the square of the applied electric field. You may get a numerical on this. Now let us talk about the pyroelectric materials. Wherever you find this root word, that is pyro, you understand it is somehow related with temperature or fire or heat. Basically, pyro word is related to fire. Fire is related to temperature or heat. So there are some class of materials which develop some charge when there is a change in the temperature. These materials exhibit spontaneous polarization. What do we mean by spontaneous polarization? I will give you a simple understanding. Even when electric field is zero, polarization is non-zero. This is how we define the spontaneous polarization. Spontaneous polarization means that the material reflects the polarization even though there is no external field present, and it is simply because of the temperature effect. The direction of polarization cannot be reversed by reversing the direction of electric field. You will understand this when we will talk about ferroelectric materials. Ferroelectric material, we are getting the hysteresis curve because of the simple reason, if you reverse the field direction, instead of applying plus E, if you apply minus E, then the direction of polarization is also reversed. But that is not the case here with the pyroelectric material. That is the case with ferroelectric materials. Now, as the temperature is increased, the thermal agitation leads to the reduction in the dipole polarization. So, if you relate, the best example is barium titanate. So, if you relate the pyroelectric materials, suppose polarization, it is going to be lambda delta T, where delta T is the change in temperature and delta P is the change in polarization. Now, this lambda is defined as pyroelectric constant. And obviously it is going to have a negative value. Why it is going to have a negative value? Because If you increase the temperature, then polarization is reducing. If you reduce the temperature, then polarization is increasing. So there is a inverse relation. Pyroelectric materials develop some voltage because of the change in the temperature, but this developed voltage is not permanent. Because of the leakage current, this voltage disappears after some time. So that is the difference between the pyroelectric effect and the thermoelectric effect in other materials. I hope you understand that. Whereas in case of thermoelectric effect, the two ends of the material are kept at different temperatures so that there is a permanent voltage across the material. But in case of pyroelectric material, this developed voltage is not permanent, it is temporary. Now let us talk about the spontaneous polarization. As I told you that spontaneous polarization is defined as material showing polarization when the external electric field is 0. Now if you want to have your GATE preparation soft copies of books, then you can download those ebooks free of cost. The link is given in the description of this video. Let us talk about the ferroelectric material. Ferroelectric material, obviously wherever you find this term ferro, you understand that there will be hysteresis curve. What is hysteresis curve? We will see. Now these materials exhibit hysteresis curve and they have spontaneous polarization, that is they have non-zero polarization even when the external electric field is 0. And the most important part is the direction of polarization can be reversed by reversing the direction of external electric field. Now these materials exhibit the ferroelectric effect up to a critical temperature which is called as Curie temperature, and above the Curie temperature they start behaving as the piezoelectric material. So you understand it like this, that ferroelectric behavior is like Mentos life, Mentos जिंदगी. Ferroelectric behavior जो है ये एक तरीके से Mentos life है और वो सिर्फ एक टेम्परेचर की एक विंडो है जिसमें अवेलेबल है. So up to the critical temperature, that is the Curie temperature, वो unique property ferroelectric behavior hysteresis curve आपको मिलेगा. But जैसे ही टेम्परेचर Curie temperature से ज़्यादा होगा, beyond the critical temperature, Curie temperature, the material starts behaving as piezoelectric material. Piezoelectric behavior is आम जिंदगी. अगर जिंदगी में कुछ नहीं हो रहा है, ferroelectric behavior नहीं है, तो कैसे behave करना है? Piezoelectric materials. Is it clear, everybody? Let us see this hysteresis curve. I will give you some important inputs. Suppose you are starting from this point, 0. This is the electric field intensity and this is the polarization. At this point at the origin, electric field is 0. Now in this direction, if you start increasing the electric field, what will happen? Slowly the material will start getting polarized, but after some time it gets saturated. Beyond this, even if you keep on increasing the electric field intensity, there will be no further increase in the polarization. Why? Because the material have already given all its dipoles for your electric field. So at this point A, you are getting the saturation. Now at this point, now if you reverse the field direction or you reduce the field intensity, a different path is followed and you get a new point B. This new point B is the residual polarization, or you can say retentivity. Retentivity means what is the remnant. बचा क्या हुआ है? इसको आप इस तरीके से समझो कि आप बाजार में घूमने गए थे, और जब आप घर लौट के आए तो आपकी जेब में कितने पैसे बचे? बात समझ में आ रही है? So at point B, whatever polarization you are getting, that is residual, बचा हुआ polarization, that is called as spontaneous polarization, and this is also called as retentivity. कितना polarization बचा हुआ है, और इस पॉइंट पर इलेक्ट्रिक फील्ड 0 है. अब अगर इस पॉइंट के B के बियॉन्ड अगर आप इस डायरेक्शन में जाते हो, इसका मतलब अब आप इलेक्ट्रिक फील्ड को नेगेटिव डायरेक्शन में ले जा रहे हो. आपने फील्ड की डायरेक्शन रिवर्स कर दी. So when you reverse the field direction, what will happen? You are intentionally forcing the material to bring down this retentivity or residual polarization to 0, and it becomes 0 somewhere here. So how much field you have to apply to bring down this spontaneous or residual polarization to 0? That is coercive field. Coercive means forcefully persuade somebody to do something. Are you able to follow this? Yes? So these are some important points: saturation point, residual polarization, retentivity, and coercivity. So this loop is defined as the hysteresis loop. You must be aware about it. So these are the details. Now when the temperature is more than the Curie temperature, the area of the hysteresis curve is shrinked and it becomes a straight line, because now the material is behaving as piezoelectric material. You can see this graph. Now what is QdVs law? Please understand this. This is important. The Curie temperature, the polarization is directly proportional to the applied temperature greater than Curie temperature. When the temperature is greater than Curie temperature, then polarization is directly proportional to the applied electric field, and this relationship is governed by the QdVs law. Now what is QdVs law? QdVs law is basically given as electrical susceptibility as C upon T minus theta. Now this T is the temperature, this theta is the Curie temperature, and C is a constant, and xi e is the electrical susceptibility. Electrical susceptibility. Okay. If you want to know how this formula came, then you can talk to me separately, because it will take some time. I will give you. Mr. Maniket, don't get angry. I'm saying you just go to the Telegram, search my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Sir. Sorry, Ashutosh Saxena. Just join that Telegram. Just after the session, you will get it. So this was about the QdVs law. Now you see, up to the Curie temperature, this is the Curie temperature, up to the Curie temperature you are getting the ferroelectric behavior. This is the ferroelectric behavior. If the temperature is increased, the susceptibility is also increasing. But beyond the Curie temperature, the susceptibility decreases very sharply. That is the piezoelectric behavior. Are you able to follow this? So for this piezoelectric behavior, we have seen xi e is equal to C upon T minus theta. So if you start increasing the temperature, the susceptibility is going to fall very fast. What are the examples of ferroelectric material? Ferroelectric materials examples are Rochely salt, barium titanate, lead titanate, KDP, alums, and sodium nitrate. Now what are ferroelectric domains? Let us understand. Ferroelectric domain क्या होते हैं, इसको समझते हैं. फेरोइलेक्ट्रिक मटेरियल में अलग अलग रीजन्स बने होते हैं, और इन रीजन्स में जो डाइपोल्स प्रेजेंट होते हैं उनका यूनिक डायरेक्शन होता है. मतलब जब तक आपने इलेक्ट्रिक फील्ड नहीं लगाई है, जब तक एक्सटर्नल इलेक्ट्रिक फील्ड 0 है, हर एक रीजन में डाइपोल्स एक यूनिक डायरेक्शन में. आप इसको इस तरीके से समझ सकते हैं कि ये एक घर है, इस घर में कई 4, 5, 6 कमरे बने हुए हैं, और हर एक कमरे में एक डीजे सिस्टम लगा हुआ है. कोई भांगड़ा कर रहा है, कोई कुचिपुड़ी कर रहा है, कोई नागिन पे डांस कर रहा है, कोई डीजे वाले बाबू पे डांस कर रहा है, जिसका जो मन डांस कर रहा है. बट एक कमरे के अंदर जितने भी लोग हैं वो सब एक ही गाने पे डांस कर रहे हैं. इसका मतलब विद इन अ रीजन all the dipoles are oriented in the same direction, but different regions may have different alignments, and that is the reason at this point of time the net polarization you are getting in the ferroelectric material is not that much high. But the moment you apply some non-zero electric field, these ferroelectric domain walls, these are the domain walls, these domain walls are going to collapse, and all the dipoles in the material, they are going to align in the direction of external electric field. I hope it is clear. Now let us talk about the antiferroelectric material. As the name indicates, anti means the dipoles are equal, but they are having the opposite alignment, equal in magnitude, but they are having the opposite alignment. And this is the reason there is, if external electric field is 0, polarization is also 0. So they do not have the spontaneous polarization because of this reason. Also, in this material, up to the Curie temperature, the material behaves as the antiferroelectric material. Again, Curie temperature तक क्या है? Mentos जिंदगी है. एक window है temperature की जिसमें Mentos जिंदगी है. So the material behaves up to the Curie temperature as antiferroelectric material, but beyond the Curie temperature, they behave as the piezoelectric material, that is the aam zindagi. The examples are lead zirconate and sodium niobate. Now there is one more classification which I am telling you, that is paraelectric material. Paraelectric materials are basically having the dipole moments which are randomly oriented, and because of the random orientation, the spontaneous polarization is 0. In the presence of the external field, all the dipoles align with the field and the result is non-zero polarization. The examples are ceramic materials. So do join my personal Telegram channel. Before that, if you want to get some scholarship, then you can attend the scholarship test on BYJU'S Exam Prep and you can get the benefits. And subscribe to BYJU'S Exam Prep app for all such important updates and sessions. And do join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Saxena, to get the PDF of this session in the previous session together. Thank you so much, friends. Take care of yourself and see you again in the next session. Thank you. Thank you, everybody.